Hello everyone, my name is Nur Amnishan binti Arif. Today my group and I will be presenting Introduction to Analog Electronics. This presentation is prepared for Puan Mariam binti Muhammad. Now I would like to introduce our team members. My name is Nur Amnisha Mimi and my team members are Nurul Ayuni, Nur Adrina, Haziatul Salwa, Muhammad Hakim and Muhammad Is Shahmi. In this slide, let's look at Introduction to Electronics. Electronics is very important because it what literally drives all our technology today, from our smartphones and medical gear to transport systems. Basically, the field of electronics is divided into two main branches, analog and digital. Now, why do we need to know both? Well, analog signal represent the real-world applications, like my voice right now, temperature, or light. On the other hand, digital system process information using binary, ones and zero, to keep things super accurate. Modern gadgets usually combine both of these to get the best of both worlds. A great example is our smartphones. When we speak, our analog voice goes into the mic, gets converted to digital, gets processed, and when it reaches to the receiver, it's changed back to analog, so they can actually hear us.
Now, let's take a look at the background theory of our topic. Before we compare analog and digital electronics, it is important that we understand the basic concept of both of these systems. First, let's take a look at analog electronics. Analog electronics uses continuous signals to process information. This means that the signals can change smoothly and can take any value within a certain range. And analog electronics are usually used to represent real-world quantities such as pressure, lights, temperature, and sounds. And some common use components in analog electronics are transistor, capacitor, inductors, and resistor. Next, we have digital electronics. Unlike analog electronics, digital electronics uses discrete signals to represent information. And these signals only have two possible values, which are 0 and 1, and also known as binary digits. Digital systems provide more accurate data storage and transmission, which are likely more reliable to these modern days electronic devices. And common use components are transistor, logic gates, and flip-flops. As you can see on the images on the right, analog signals appear as smooth continuous wave, while digital signals are represented by a square or a pulse-like wave, showing only two logic levels, which is high and low.
In this section, I will explain the circuit operation of analog and digital system, followed by a comparison between the two systems. First, let's look at the analog system. An analog system processes continuous electrical signals, meaning the voltage changes smoothly according to the input signal. Since real-world signals such as sound, light, and temperature are naturally analog circuits are widely used in electronic devices. As shown in the diagram, the operation starts when the microphone receives sound wave and converts them into analog electrical signal. Next, the signal is sent to the amplifier. The function of the amplifier is to increase the signal strength while maintaining its original waveform. Finally, the amplified signal is sent to the speaker, which converts the electrical signal back into sound wave. In short, the analog system follows four main stages: sound to microphone, to amplifier, and then speaker. Now, let's move on the digital system. Unlike analog system, digital system process information using binary values, which are 0 and 1. The operation begins when the microphone receives sound and converts it into an analog electrical signal. Since the processor can only process digital data, the analog signal is first converted into binary data by analog to digital converter or ADC. Next, the processor performs operations such as storing, filtering, or processing the digital information. After processing is complete, the digital to analog converter or DAC converts the digital data back into an analog signal. The signal is then amplified before being sent to the speaker, where it is converted back into sound. Therefore, the digital system operates in this sequence: microphone to ADC, to processor to DAC, to amplifier, and then speaker. Now let's compare both systems. The main differences is how they process signals. The analog system processes continuous signals, while the digital system processes binary signals, represented by 0 and 1. In terms of circuit components, analog system mainly use microphones, amplifiers, and speakers. On the other hand, digital system include additional components such as the ADC, processor, and DAC to perform digital signals processing. Analog systems are generally more sensitive to electrical noise, whereas digital systems are more resistant to noise and provide better accuracy for data storage and processing. In today's technology, most electronic devices combine both systems. For example, a smartphone uses analog circuit to capture and reproduce sound, while digital circuits process, store, and transmit the information.
Hi everyone, so for my part, I will explain about relevant equation and analysis. I will compare analog and digital system using mathematical equation. Analog uses the AC waveform equation Vt equal to V peak sine 2 pi Ft plus phi, which represent a continuous signal with infinite value. Basic laws like Ohm's law, V equal to IR, are used for circuit analysis. Digital uses the Nyquist theorem Fs greater than 2F max, which convert continuous signal into discrete signal. The quality is measured by resolution 2 to the power of n, where more bits mean higher accuracy. In summary, analog is more natural and accurate, while digital is more precise and noise resistant. Since the real world is analog, we need ADC and DAC converters to bridge both systems. Thank you.
Okay, for this part, I will explain the advantages and limitation of analog and digital signal. Let's start with the analog signal first. If we look at the advantages, analog signal is very good at representing real-world signal because it changes continuously. That's why it's very suitable for audio and video application where the sound and image can be produced more naturally. Another advantage is that analog circuits are usually simpler, so they are easier to build and implement for basic electronic system. But of course, analog also has its weakness. Since it uses continuous signal, it's easily affected by noise and interference. As the signal travels over a long distance, the quality can become worse. Besides that, it's more difficult to store without losing quality and it's less secure than digital communication. Now let's move on to the digital signal. One of the biggest advantages of digital is that it much less affected by noise because, as we know, it's only used two binary values which are 0 and 1. So even there are a little interference, the system can still recognize the correct data. Digital system also support encryption, compression, and error correction, making them more suitable for storing data and transmitting information over long distance. However, digital is not perfect either. It needs more complex hardware, consume more power, and may require higher bandwidth. So, both analog and digital signal have their own strength and limitation. That's why most modern electronic devices combine both technology to achieve better performance.
Next, I will explain the real-world application of analog and digital system in daily life. Although digital technology is widely used today, analog systems are still important because real-world signals such as sound, temperature, and also pressure are naturally analog. So this is why most modern electronic devices combine both analog and also digital system to perform efficiently. So for the first application is communication. In the past, analog systems were used in AM or FM radio and traditional landline telephones. This system use continuous signals, but they are easily affected by the noise and interference. As the transmission distance increases, the signal quality will become weaker. So today, digital systems are used in smartphones, fiber optic networks, video conferencing, and also internet communication. Before our voice is transmitted, it will be converted from an analog signal to digital data. So this will allow the communication to be more faster, clearer, and more secure than traditional analog communications. And then the second application is in healthcare. Our body naturally produce analog signals such as heart rate, blood pressure, and also temperature. So the medical sensor first detect this analog signal before converting them into digital data for processing and also analysis. This technology will be used in devices such as ECG machine, MRI scanners, CT scanners, and also digital thermometers. As a result, doctors can diagnose diseases more accurately, monitor patients more effectively, and also provide a faster treatment. And then the third application is consumer electronics. Another important application is consumer electronics. In older devices, such as cassette player and analog television, they are mainly use analog technology. But today, most electronic devices, including smartphones, laptops, smart televisions, and also digital camera, use digital system because they provide better image quality, clearer sound, faster processing, and a larger storage capacity. However, analog systems are still needed. For example, a microphone receives a sound as an analog signal, while a speaker converts digital data back into sound that we can hear. So this shows that both systems work together in modern electronic devices. And then the last application is industrial automation. Factories use analog sensor to measure physical condition such as temperature, pressure, humidity, and also vibration. These analog signals are then converted into digital data and processed by the programmable logic controllers or PLCs to control the machine automatically. This will improve the production efficiency, reduce human error, increase product quality, and also create a safer working environment. Therefore, both analog sensing and digital processing are essential in modern manufacturing industry.
So, to wrap things up, both analog and digital play massive role in our daily life. It's not about one replacing the others, they actually need to work together. Analog handles the messy reward sideness, while digital makes sure the data processing is fast, accurate, and efficient. That's why understanding both systems is absolutely essential for anyone studying electronics and engineering.
These are the references we use to prepare this presentation. They include textbook, journal article, and trusted online resources to ensure the information is accurate and reliable. Thank you for your attention, and we hope you found this presentation informative. Have a nice day.